moving on to question 2 now, we have a question here dealing with the Poisson distribution. And how do we know it's the Poisson distribution? Well, looking at our question here, we're told that in a certain period time here, so 4 hours, that there's a certain amount of calls, and then the next part is asking in another time frame how many more calls might arrive. So whenever you see the data that you're looking at in terms of a certain time frame, it's going to be Poisson. Okay, so we're looking at Poisson here. So Poisson. So for part A, it just says using a suitable model, find the probability of more than 4 calls arriving in a particular 20-minute period one morning. So we're told in a 4-hour shift, there's on average 8 calls. So this is just a reception, and then there's calls coming through. So in 4 hours, 80 calls. Okay. Well, we need to know for a 20-minute period. So we've got to adjust this now. Okay. So for 20 minutes. So for 20 minutes, how many calls will there be? Well, you can divide this by 4, so that'd be 20, and then divide it by 3 to get your 20 minutes. So 8 divided by 4, that'd be 20, and divide that by 3, so that'll be 20 over 3 calls. Okay, so we can model this as a Poisson distribution, so we say X multiplied by PO, and here our lambda value is going to be this 20 here. This for the 20 minutes, so it'll be 20 over 3. Okay, now we just need to work out the probability that X is greater than 4, so more than 4 calls arriving. So probability X is greater than 4. So that's the same as 1 minus the probability that X is less than or equal to 4. Okay. So again, up to here now, you can use your tables, or you can just put it on your calculator. They won't penalise you for just using the calculator at this point once you've shown all the previous working. So at this point here now, to 3 significant figures, this is 0.794. And there we have it. That's the first 3 marks. Quite a nice introduction there, part A. But part B and C get a bit trickier. I've got a bit more going on. So it tells us that she's allowed 20 minutes of break time during each 4-hour shift, which she can take in 5-minute periods. So what it's asking is that if she takes her break time in 4 periods of 5 minutes each, can we work out the probability that in exactly 3 of these periods there were no calls? So how do we do this? Well, let's just work out one individual break first. So one break. Okay, so that's 5 minutes. So 5 mins. Well, we knew that for 20 mins, it was 20 over 3. So 5 mins. That's going to be this divided by 4. So times it by 1 over 4, so you're going to get 20 over 12. Which will simplify to 5 over 3. So 5 over 3. Okay. So we've got our new PO value here, our lambda. What I've got to do now is work out the probability that X is equal to 0 for one of these. So probability that X is equal to 0 using lambda is equal to 5 over 3. So if you do this on your calculator, what you'll get is 0.1889, right? So we've got that one there. So this is my probability of there being no calls in one shift. Now, we've got this, we've got a fixed number of trials, there's 4 periods. So now we can use a binomial distribution, okay? So if I say that Y is modeled by a binomial distribution, where my N, so there's 4 breaks, so that'll be 4. And the probability is this here. That's the probability that there's no call. So 0.1889. Okay. And we want to know that the probability in exactly 3 of these periods. So I'm working out the probability that X is equal to 3. Okay. So the probability that X is equal to 3, plugging this in your calculator again, you'll get 0.0219. Just 3 significant figures. And there we have it. That's part B. So I'll just quickly clear all this. Now for part C, it says on another occasion, she takes 1 break of 5 minutes and 1 break of 15 minutes. So find the probability that she missed exactly 1 call in each of these 2 breaks. So we're going to model this with 2 different situations here now. So I'm going to have the situation where X is distributed with a Poisson distribution, and it's going to be 5 over 3 for 5 minutes. So 5 minutes, like we already said, that's lambda equals 5 over 3. So how do we get 15 minutes? Well, I can just times this by 3, right? So 15 minutes times this by 3. So therefore, lambda is going to be equal to 5 over 3 times 3. So that's going to be 15 over 3. Okay, so we've got 15 over 3 there. Let's work out each individual one now. So we're going to have x is lambda with 5 over 3, and then we're going to do another one again. Again, I'll call this one just x. Being a bit lazy, but call that one 15 over 3. Okay. So what we've got to work out now is the probability that x is equal to 1 for both of these, and then just times our answer, and we've simply got it. So the probability that x is equal to 1, because it's exactly 1 call. So probability that x is equal to 1 for both of them. Okay, so if I do this one first, using lambda is equal to 5 over 3, this will be 0.3147927. Okay, so I'm going to keep all my accuracy just because I don't want to lose any degrees of accuracy in my final calculation. And for this one here, this will be 0.033, I'm losing my voice, 0.03368973. So therefore, my final answer, probably that x is equal to 1. It's going to be this times by this. So it's going to be 0.3147927 times, so I'm going to write all this out just to show clearly, 3368973. Performing this calculation now, you're just going to get 0.0106. And there we have it, that's question 2 fully complete.